Hey, welcome back to part three. Hey, I believe the last time I was with you, we were finishing up 14. I accidentally erased part of this problem, but let me go ahead and just start right there a minute. And I want to slide this over. Oops, sorry. Okay. So on number 14, remember we did 7 to the x power equals 1 over 49. Which is 7 to the x power equals 1 over 7 to the second. Remember, you want to have the same number on both sides. So 7 to the x equals 7 to the negative 2, because anytime you have a fraction, you can put that up top and make it a negative 2. And so my final answer would just be x equals negative 2, because again, the bases cancel out. So number 14 would be negative 2. Okay, moving on to 15, set this equal to x, and you would get 3 to the x power equals 1 over 3. So 3 to the x power equals 3 to the negative 1. That's another way to write 1/3. And so the bases cancel out, and you get x equals negative 1. On number 16, set it equal to x, or any letter. You get 4 to the x equals 1 over 256. So 4 to the x equals 1 over 4 to the 4th. Because 256 is 4 to the 4th power. You want to put that up top, so that becomes 4 to the x equals 4 to the negative 4. And again, the bases cancel out, and your final answer would just be negative 4. Finally, the very last one is number 17. I would set it equal to x. So I would get 9 to the x equals 9 to the n plus 1. And we're trying to figure out what x is. So if you look carefully, the bases cancel out, and x is really just n plus 1. So on this one, you don't get a number answer. Your answer would just be n plus 1, because that's what x, or whatever you're setting it equal to, equals. Okay, hopefully that helps you. All those problems are kind of done the same way. So I know I'm going kind of fast, but since those were all very similar to the ones I did earlier. Okay, now on this section it says solve each inequality or equation, check your solutions, okay? So what we're going to do is we're going to use the method that Miss Brewer uses, which is called you drop in the base. So the opposite of logging is taking something to that power. So if you want to get a log base 10 out of here, what you can do is take both sides and put a 10th power right here. You can drop in the base. Now these will end up canceling each other out, and you just get n equals 10 to the negative 3 power, which means n equals 1 over 10 to the third, which is 1 over 1,000. So I believe the answer to number 8 would be 1,000. Now, one thing to remember on these problems, and I think Ms. Brewer probably covered this in the notes, is that this number right here cannot be negative. It always has to be positive. That's a law of logs, where you cannot have a negative number in that particular spot. You can have a negative over here, but you can never have a negative there. So you have to watch out for that as you're doing these problems. So, number 19. Again, even with inequalities, you can drop the 4 in here. These will cancel out, and you get x is greater than 4 to the third. So x is greater than, I believe that's 64. Okay? Now, as long as it's bigger than 64, I think we're good here. And if you take this x right here, remember x has to be positive, so it has to be greater than 0. So it already is greater than 0, so we're okay. If we got x is greater than negative 2, we'd have to be careful to make sure that it's actually greater than 0, because some of those numbers would work and some of them would not. Okay, the next problem, again, you got a 1/5 for your base, so you take both sides and you put the 1/5 in for the base. These cancel out, and you get x equals 1/5 to the negative 3 power. That flips and becomes 5 over 1 to the positive 3. That's one of your exponent rules, which would be 125. And again, as long as that's a positive, you're good on the check part. Okay. The next one, you can put a 7 in. These would cancel and you would get Q is less than 7 to the 0 power. Remember, 0 power is really just 1. So Q is less than 1, but remember, Q has to be greater than 0 by definition. So on this one, you do have to be careful. You have to say Q is, it can't be greater than 0 and less than 1. So basically, the answer to this one would be no solution. Because how can Q be greater than 0 and less than 1 at the same time? It can't. So that means there's no solution to this problem. Okay, moving on. Number 27, the base is y, so I'd put a y on both sides like this. These would cancel out. 16 equals y to the negative 4 power. So that means 16 equals 1 over y to the 4th power. And now how do you solve that? Probably the easiest way is to multiply both sides by y over 4. So you would get 16y to the 4th equals 1, because these would cancel out. You would then divide by 16. So y to the 4th equals 1 over 16. How do you get rid of a 4th power? You 4th root it. And that happens to be a perfect 4th root because the 4th root of 1 is 1 and the 4th root of 16 is 2. And so the final answer to this one would just be 1/2. Hopefully that all made sense. Okay, now the next problem, when there's a log on both sides and they both have the same base, you can literally just scratch them out because both sides are identical except for what's in the parentheses. So basically, if what's in the parentheses turns out to be equal, then the whole equation would be equal. So I would just do this. And then you subtract x. So you get 7x plus 20 equals 6. You would subtract 20. You would get 7x equals negative 14, and then you divide by 7, and you get negative 2. Now, you notice at the top it said check your solution. On this particular one, you need to plug negative 2 back into here. Negative 2 plus 6 is positive 4, so that's okay. And negative 2 plugged into here would be negative 16 plus 20, which is also 4. So this answer checks out. So the way you check it is to plug it back in. Make sure you don't get a negative. Okay, number 24, again, as long as there's a log 8 on both sides, you can scratch those out and just say 3x plus 7 is less than 7x plus 4. Now solve. So minus 3x is 4x. Minus 4 is 3. Divide by 4. You do have to be watching out for sign changes because if you divide or multiply by a negative, you have to change the sign. But you would get x is greater than 3/4. Or you could write that the other way. X is greater than 3/4. Now, on this one, you do have to be careful. You actually have to take this and make sure that that's okay. So you're going to go, remember this cannot be negative. So I would say 3x plus 7 has to be greater than 0. So 3x has to be greater than negative 7. Divide by 3. X must be greater than negative 7/3. Well, if it's greater than 3/4, is it greater than negative 7/3? Yes, it is. So that's okay. Then you take this part and you do 7x plus 4 has to be greater than 0. So 7x has to be greater than negative 4. So x has to be greater than -4/7. Again, if it's greater than 3/4, is this being met? Yes, it is. So we know that this is a legitimate answer because if we plug it back in, we will not get negatives. Instead of doing all of this stuff, you also could plug them back in, although sometimes it's safer to do it the way I did it over here. Okay, last one. If you have a base of n, you would just do n and n. These would cancel out. You get 1/8 equals n to the -3. So that's 1/8 equals 1/n to the +3. Remember, negative exponents turn into fractions. And then actually there's a cool trick on this one. You can flip both sides and just say 8/1 is equal to n to the 3/1. Because that's legal to flip both sides of a fraction, or you could cross multiply, you would get the same thing. So you get n to the 3rd equals 8. The opposite of that is to cube root it. So n would be 2. And again, if you look at that, that's okay to plug a 2 right there. So 2 to the -3rd power would be 1/8. Okay, cool. That wraps up all of this. We're moving on to the last page. Now, when you get to the last page, there's really two kinds of problems. These problems are very different than the ones below. On these, you're trying to use your properties of logs to help you solve it. Now, you know that the log base 2 of 3 is 1.58. And you know that the log base 2 of 5 is 2.3219. So, basically, how is that going to help me solve this problem? Well, you have to think of a way to turn 15 into something that has a 3 or a 5 in it. So this is what I came up with. The log base 2 of 3 times 5. See, 3 times 5 is the same thing as 15. So, but why would I do that? Because 3 is listed right here and 5 is listed right here. So that's a much better thing than 15. Now, in the land of logs, if you have multiplication, you can split this into the log base 2 of 3 plus the log base 2 of 5. That's a property of logs that Miss Brewer taught you about in 10.3. Then you simply plug in the decimals up above. So the log base 2 of 3 is 1.585. Plus the log base 2 of 5 is 2.3219. So if you add those two together, sorry, I have to jump over here and use a calculator real quick. 1.585 plus 2.3219 gives me 3.9. So this is equal to 3.9069. So that would be the answer. So basically I split 15 into 3 times 5. Once I got this multiplication problem, that's split into addition, and then I plug in the decimals and I finish it. Okay, that's problem number 1. Number 2, you should have also learned that division in logland means subtraction. So this can be turned into the log base 2 of 5 minus the log base 2 of 9. Now we know the log base 2 of 5 is 2.3219. But what do we do with this guy? Well, 9 is like 3 to the 2nd power. So I change this into 3 to the 2nd. And remember, if there's an exponent in front of here, we can put it right there. That's another property of logs. And turn it into 2 times the log base log of 3. Log base 2 of 3. Okay, now, stay with me here. This is over here. It's 1, so it's 2 times 1.5850. So, real quick, 2.3219 minus 2 times 1.585 is 3.7, and then I subtract those. 2.3219 3219 minus 3.17 gives me negative 0.8481. And we're done. We'll finish this on the last video. Thank you.